All right, boys and girls, today we're going to talk about adding and subtracting fractions with like denominators, or sometimes called common denominators. So this really is just a review from fourth grade. This should not be a very difficult skill for you. You did this last year as fourth graders. There's a little bit extra that we're going to throw in fifth grade that is different. It's not real hard though. I think you guys should handle this pretty good. One of the things, really, what's kind of interesting about what we're about to get into is when we start adding and subtracting fractions, you will just see a lot of what we've been learning about the last couple of weeks. And so let's kind of talk about it. This first page here, this is just some examples to look at. This is pretty basic. There's, 3 problems on the page. This is very close to what you guys will be seeing on this lesson. So the top one, it has models for you, but the one thing I want to kind of emphasize or make sure that you understand is this is what is called adding and subtracting with like or common denominators. So your denominators are the same. And that makes your life a little bit easier because when they are the same, then basically all you're doing is you're just either adding or subtracting the numerators. For example, in this first problem, 1 plus 2 gives you 3, and then you're just going to keep fifths in your answer. So you start with fifths in your problem. You also have fifths in your answer, and so you have 3/5 as a final answer. One of the things that I will say is going to be kind of the new part, this is different from fourth grade, is when you're solving a problem, you always have to stop and ask yourself, okay, is that my final answer? And what I mean by that is when you get a fraction as an answer, you always have to ask yourself, can that fraction be simplified? Well, from last week's lesson, and kind of talking about what simplifying means, simplifying is a way to find an equivalent fraction using division. So when I look at 3/5, I would think to myself, is there anything that can go into both 3 and 5 so I could simplify it? And that answer would be no, there's not. 3/5 is just 3/5. It is already simplified. So I would put a check mark there and go, okay, I can't do anything else. Same thing with the middle problem here. 1/7 plus 4/7. That's super easy. 1 plus 4 is going to give you 5. 5/7. Now you'd have to kind of stop and think, can that fraction be simplified? Well, if I think about my rules for simplifying, one of the rules states that if you have a prime number as the numerator and a prime number as the denominator, then it is a simplified fraction, which this one is, because 5 is prime and so is 7. So 5/7 can't be simplified, so it is a final answer. And then, of course, the last one's already one that we've seen, which is just a subtraction problem, though. We've got 4/5 minus 1/5. You just subtract 4 minus 1, you get 3. And then, of course, 3/5 we've already discussed as a final answer. Okay, this second page, there's several problems here. I am not going to work all of these problems, but I am going to pick out a couple of them just to show you where your mind has to be when you solve these problems. Because last year in fourth grade, you probably would have been able to get away with this, and it still would have been a correct answer. But now that you're in fifth, you're going to have to change your thinking a little bit. And I'll explain what I mean by that. So I'm going to circle a couple of these problems. I'm going to do an addition and a subtraction problem with you, but really watch what I mean by if it's a final answer. So let's start with number 3. This problem's super easy. It's 3/8 minus 1/8. So your math here is very simple. 3 take away 1 is 2. And so I'm going to keep eighths, but here's my dilemma. When I get this final answer, I have to stop and think, can 2/8 be simplified? Well, 2/8, that's a fraction that if I really think about what it means, 2/8 has an equivalent fraction to it. In other words, 2/8 can be simplified. So I would take 2/8 now and I would think, what is the number that can go into both 2 and 8? Well, from everything we've been learning about, your divisibility rules tell you that 2 and 8 are both even. So 2 can go in. So I would divide it by 2 over 2 and think, okay, well, 2 divided by 2 is 1, 8 divided by 2 is 4, and now I have a final answer of 1/4. This is what I tell my students. Sometimes my students will ask, well, what's the reason for doing that? Well, you're showing, think of it like this. Your math skills are getting to a level now where when you see a fraction like 2/8, you have to know that, hey, 2/8 is the answer, but really it could be 1/4 because they're equivalent to one another. And so you have to really have that skill of going, okay, well, hey, if it can be simplified, I have to take that extra step to do it. Because think of it like this. If this is a multiple choice answer and it's A, B, C, and D, and you solve this and you get 2/8, but 2/8 isn't there, then you have to have the skill to go, okay, well, what else could 2/8 be? Well, 2/8 could also be 1/4, and I would be willing to bet 1/4 would probably be there. So it's a skill, and again, this is a skill that lasts a long time. You have to be really good at this. All right, let's look at number 5. Number 5 is 3/20 plus 1/20. Well, 3/20 plus 1/20 is going to give you, if you just do the math there, the math's really simple, it's going to give you this answer of 4/20. Well, 4/20. What do I know about 4/20? My thought process in my head would be, well, where could I go with 4/20? Could it be simplified? Sure, it could. Now, here's where you're going to have to be really, really careful and think, okay, if I know my facts and I know if I think about it long enough and hard enough, I could probably think, well, what is the biggest number that could go into both 4 and 20? Well, I know 2 could go in because they're both even, just like on the last problem. But if I know my facts, I think 4 could actually go in. And that would be what's known as the GCF. That's why we did greatest common factors. If you factored 4 and you factored 20, your GCF would be 4. So therefore, you would divide. 4 divided by 4 is 1. 20 divided by 4 is 5. And now you have this final answer of 1/5. So again, don't overthink this stuff. The addition and subtraction is going to be the easiest part. The part that most of my students in the past have struggled with is that little bit extra, which is what I was talking about at the beginning of the video. This is the little bit extra that you're going to have to do in 5th grade. All right, here's a new scenario. So you could be facing a problem where you're going to either add or subtract and your answer goes over a whole. Meaning, this problem here is 4/5 plus 6/5. Well, I would probably stop and talk to my students about, well, what do we really know about this problem? Well, I would hope most students would look at 4/5 and go, well, 4/5 is almost a whole already. It's a fifth away from being a whole. 6/5 is already over a whole. But now I'm going to go add the 2 up to get an answer. I'd have to be really, it's almost like when I'm solving this problem in my mind, I'm going, okay, I already know where this is about to take me. And in my mind, I would be thinking, this is going to give me an answer that's going to go over a whole, or it's what we just got through talking about. This is probably going to be a mixed number. This is going to be a whole number and a fraction next to it. So let's talk about how you would solve this. This is going to be, one of those where we're going to have to kind of stop and think. So 4/5 plus 6/5, first of all, my math's not going to change here. I'm still just going to go and add the numerators. Well, 4 plus 6 is 10. All right, my fifths are going to stay the same. And now I'm looking at an improper fraction as an answer. Again, I know that's improper because my numerator is bigger than my denominator. And again, you know that from 4th grade. That's not anything real new. But what I have to think about is, okay, well, what's my next step? So I'm going to put an equal sign next to this, and I'm going to think, well, what do I have to do next? Well, this one's kind of unique. So first of all, if it's improper and I want to change it or convert it, I have to think, well, all right, well, how do I convert improper fractions? And I'm going to go back to that bar right there. That bar basically is just a division symbol. So this problem really is just 10 divided by 5. Well, 10 divided by 5 is a math fact. And so 10 fifths, or 10 divided by 5, really is just the whole number 2. And if you really kind of think about this, at the beginning I said, well, maybe this is going to give me a mixed number. Well, a lot of them could, but this one's not. This one's going to give me a whole number, because I'm sitting there and I'm thinking, okay, if I have 4 fifths and then I had another 6 fifths and I added them together, if I drew this out in a picture, I'm thinking, okay, well, 4 fifths and 6 fifths, those just give me 2 wholes. And so, like I said, it's kind of a unique problem. They're not all going to look like this, but that's the approach I would take on a problem like this. Okay, the last problem that we're going to look at is going to be one where we might have to do a couple of things. So really watch and kind of think about everything that I'm doing to get a final answer. What's interesting, though, is everything that's on this problem basically is everything we've been doing the last couple of weeks. It's just kind of all rolled into one problem. So if you've been wondering, well, why have we been doing this stuff? This is why. So I'm going to start with the addition problem. First off, I'm just going to put a fraction bar and write 20ths, because I already know I have like denominators, so it's going to stay 20ths. Now, 18 plus 12, if I were to do that math, I could do it two ways. I could think, well, that could be a mental math problem, or I'm going to write it out to the side. There's no shame in that if you had to do that. I think 18 plus 12 is going to give me 30. And so now I'm looking at the answer of 30 20ths. Well, 30 20ths is an improper fraction. So I'm already thinking, all right, that bar right there is a division problem or division symbol. So this is 30 divided by 20. So I can set it up in a house and I could solve this traditionally, which is perfectly fine. Or I could maybe take more of a mental approach and just think, okay, well, how many times can 20 go into 30? I'm going to solve it out traditionally just so you can see it. So 20 can go into 30 one time. If you did 20 times 2, that takes you to 40, and that's too much. So 20 times 1 is 20. You would subtract. You're going to have a leftover or a remainder here. So you're going to have this answer of 1 with the remainder of 10. And these numbers are so friendly, I think you guys would agree with that. This is a pretty easy problem. Now, I have to stop and think, okay, well, if I work that problem, then I probably am going to get something from that division problem, which this is all going to roll back into where an improper fraction should go. An improper fraction should turn into a mixed number, which on this particular problem, I'm going to say my mixed number is going to be 1. I got that 1 from my division problem. That's how many times it went in. My numerator is going to be my remainder, which I had a remainder of 10. And my denominator is going to be basically my divisor, which was 20. And again, from some of my videos that I've made for you guys, remember on these, the denominator's not going to change. It's going to stay the same. All right, now I have to go and take it a step further. You know, I always tell my students what sometimes gets frustrating about these problems is it takes a while to get a final answer. But it's not hard math if you've been paying attention. My last step would be I have to look at that fraction and decide, can that fraction be simplified? Well, think about 10 20ths. I'm not looking at the 1. The 1's going to stay the same. I'm just looking at the fraction 10 20ths. Well, I would hope most of my students see 10 20ths and already know something about 10 20ths. I would hope most of them see it as a benchmark fraction or the fraction half. 10 20ths is just a half. I tell my students quite a bit, you need to learn your half fractions. They're so important. They're very, very popular. And when you know your half fractions, it just makes your life easier. And so I would say, really and truly, let's just call this a half. I'm going to show the work, though, that would go into it, which would be you would have to divide 10/20ths by your GCF. Your GCF would be 10, and that would give you the fraction of a half. Now, if I look at what I want to do here for a final answer, I want to keep my 1. I'm going to write my 1/2 next to it, which is now officially my final answer of 1 1/2. So, kind of thinking about everything that we did on this page, you kind of see everything that we've been working lately. So you see some simplifying on this page, you see some mixed numbers and improper fractions on this page, and then you see what we're going to be trying to do before our Christmas break, which is just adding and subtracting fractions with what are called like denominators.